Thank you. Welcome to my talk. Thank you for staying until the last talk of the day. I hope I don't put you to sleep. Well, my talk is about Flutter, as you can see by the title, Dart, I'm your Flutter. As mentioned, I'm an Android developer by day. I usually work in Kotlin code all day, but I'm also interested in creating cross-platform applications, because if you can do something once and have that run on 2 devices, that's always a lot better than having to do things twice. Well, I made a little meme, Flutter, Dart, I'm your Flutter. As you can imagine, I'm quite a Star Wars fan. Well, if you want to get started with Flutter, Flutter is an SDK for creating cross-platform applications for Android and iOS. It's really easy to get started. Just download the SDK from the site, get an IDE like Android Studio, IntelliJ, Visual Studio, and install the plugins there. That will get you set up running a Flutter project. And what I did is I created a little workshop to get familiar with how to create an app in Flutter. I already have it open, which you can get in GitLab. I'll share all the links after the presentation, so you don't have to take pictures of the URLs to remind them. So basically what you start with is make everything smaller, and there should be an emulator running. Whoa. So what you start with is, if you start with my workshop, you get a little sample application that has just a starting page with a greeting text. And let me talk to you a bit about how the project works. As you see here in the project view, you have an Android folder, which basically just contains an Android project, like you would normally have when you do Android development. Besides an Android folder, you have an iOS folder, which is basically the same for iOS. It's just a normal Xcode project. If you want to do native code for iOS, you just open this project and you can do that in Xcode. Then you have a lib folder, which will be where you'll be working most of the time. This will contain all your files that you write in Dart. You have a test folder where you have your unit tests. And then you have a YAML file called popspec, which is for managing dependencies, the same way as you would for Gradle in Android or podspec in iOS. You can just provide here in the dependencies block the dependencies you want to have with your application. The dev dependencies are for compilation or running tests. And below that you have a Flutter block, which is specifically for the Flutter framework, where you can add images which will be shared on both platforms. Or for instance, if you want to have your own fonts, you don't have to go to the Android project and put them there and also know where to put them in the iOS project. You just create a new folder and specify that here, and then during compilation the tool will put them in the correct place for you. Basically, now what you have is a really simple application, one page with a title and a simple text, which is started in the main.dart. If you know, for instance, Java, you also have like a main class which has an entry point called static void main. In Dart, it's called main, and where you have to call run app, and you pass a widget in it, as defined here by my app. In Flutter, everything is a widget. Flutter is basically a UI framework that runs on both devices. So it's more targeted at creating UI than it is on being a framework for platforms that you run on. And they chose to use widgets to create your view components with. As you can see here, a stateless widget, which is a widget that gets created once and doesn't change during the lifetime of the life cycle of where it's running in. So this is the top widget of the whole application. So you start that once, and that gets kept around for the entire life cycle of the application. Inside you have a build method, which is kind of similar to how, for instance, React has a render function, and in that function you specify what needs to be shown on screen. So we're currently creating a material app, which already provides the basic structure of how the application is going to look. Like you have the toolbar, the body content that you would have normally used for any information that your app has, lists or whatever. And we specify a theme with all the colors. One of the nice things about Flutter is that it has a hot reload function. So if I would change this green, normally on an Android project or an iOS project, you would have to recompile the application, then reinstall it on your app. You have instant run, but usually that doesn't work or breaks down. So now it should rebuild a new app, or only the part that changed, and it changed the color of the title. This also works if you have like a form with 6 pages and you filled out 3 of them and you change something, it will just reload that part, and you don't have to restart the app, go through the entire form again, and then see if you fixed the issue or changed what you wanted. Basically, we now have just the simple text, but what we're going to do is we're going to create an application that will show us a list of Star Wars movies, like here. Oh. It will get movies from the movie database, show them in a grid list, and then if you click them, it should open a information screen which has the information about the movies. So basically, as I mentioned, everything is in Flutter is a widget. That means few components don't have a lot of attributes that you can set to change how they look. You have to nest them in other widgets. Like, for instance, this text view, its only concern is rendering the text. Maybe the styling of the text can change, the font, but that's its only job. If we want to position that somewhere else in the screen or center that in its parent, for instance, you would have to wrap the text widget in a center widget, which makes it really a fast way of rendering a UI, because now it only has to do one layout pass to figure out how to position and lay out the entire views, versus, for instance, on Android, there can be multiple passes if it tries to figure out, hey, I need to put this here, and it's only so many percentage of the screen, and then we have something here. It tries to figure out this, then goes back, and in Flutter, they made it that everything starts at the top and then starts going down and rendering the screen, which makes it a lot faster than you would used to know on Android. So this is now centered, and it has a padding. Like I said, everything is nested into each other. You do have to watch a bit, like this is already a lot of code for doing something really simple. If you make more complex views, it's better to start extracting out them to separate classes, so you can create a high-level component for something that is reused maybe a lot in your app. I'll go to the next step, version control, check out. So, in the next step of the first step of the presentation or the workshop, we're going to retrieve the API data and then pass that to the screen. This is the second one. So basically, we create an API class which has a JSON decoder for serializing the JSON data, and we have a method which is asynchronous. Flutter runs in Dart, and Dart provides us with an async await kind of structure that you might know from JavaScript. So we await for the HTTP request to return with the data, then we convert that body string that we get to a map of string and dynamic. You could already work with that map because it contains all the data, but then it isn't typed, so you find the value by the key and you don't know which type it is, and if there are some inconsistencies or if you're working in a larger team, it can be really cumbersome if nobody knows which type is what. So what we're going to do is that map that we get, we're going to convert that to an actual class. And we've created I've already created all the classes, which is really simple. Well, if you're used to Java, it's a Pojo. In Dart, it's a Dojo, I guess, plain old Dart object, which just has the key of the JSON is the field name, and it will contain the data as the type. So, for instance, we have the movie search result collection, contains a list of movie results and a page number, total number of results, and a total number of pages. Normally, you would use something like reflection to easily map those things together, but to make Flutter run fast on mobile devices, what they did is they removed the reflection part of Dart. So, and now we have to create this code with a tool that will generate it for us. So, I need to update the dependencies. So this tool is a library called JSON Serializable. The Flutter team also recommends using it. There are other libraries that also do the same that work a little bit different. You just annotate the class you want as a serializer to be serialized, the names of the fields, and then it will generate the code for us. And there should be a new file here. It's not giving any warnings, so seems the file is generated, but we're not seeing it in the files list. Yeah, now it turns up. Basically, this is kind of simple code, but it's really cumbersome to write. It's really verbose. It's just mapping the key from the JSON to the field in the class and then writing the data to it. So it would be really cumbersome to write a lot of that code a lot of the time, so that's why they chose to use code generation for it. So now we can do the API call and retrieve the data, and then we want to at least do something with that. So currently I'm using the init state, which is a method in the widget that is called every time the widget is created. So here we have the API client where we call the get search movie results, and then when we receive the value, we'll just print it in the log. So if we reload this, because the application is already running, it doesn't recreate the widget. So if we restart, it should start printing out the files. I've noticed that lately the caching seems to not always work. As you see, it printed out all the movies to the log. Well, that's already shows that it works, but for a user that wouldn't be really handy. So what we're going to do is now we're going to create a grid view, which will just print out the titles of the movie and then show that in the list. So if I switch to that commit, the only thing that we've changed now is that we've created our widget, which will show the grid view. Basically, in Flutter, they already thought about the asynchronous part of getting data. So they provide a widget out of the box where you can pass in the async method and then look at the state of the call and decide what you want to do on it. So this async snapshot connection state is an enum which contains some states that it can have. Waiting means it's still loading the data. Active, that it is actively getting the data and it has returned at least one result. And done, that it's been terminated, or none, that if the future is not running at all. So now if we rerun this application, I made a little boo-boo in the presentation. I was not checking the data correctly. So here I'm checking the state of the snapshot. If it's waiting, we show a loading text. If the connection is already done or we have the data, we check if there was an error. If there was an error, we show an error message. Else we'll start creating a list which has the titles. So if I'll reopen it, it will show. I think they broke something with the hot reload in the last few versions. As you see, it switched from the loading state to the showing of the list. And this is just simply a grid list with each grid tile having the title of the movie. It's already getting somewhere, but it isn't really user-friendly or doesn't look nice. So in the next step, we would start creating the list items. The version control. counts. So here we basically have the same kind of method we had before. We await for the async method to finish, show a loading spinner or an error message if something went wrong. Else we'll update the list of movies that we have and show them in the grid. The movie grid is now extracted to its own class to make it more readable, because else if you would keep on nesting, the code would really not be readable anymore. So we've created a simple widget here which initializes a grid builder, and we pass the length of the movies list we get from the API, and in the item builder you get a index from the list and a build context, and what the method should return is just another widget which is going to be the list item, which in this case is a material card which will show a image of the movie poster, and in the footer, like we have below already, it's going to show the title and the release date of the movie. So if we rerun this, it's loading the data, and it starts loading the views. So basically we were already starting to create an application that gets the data, shows it nicely to the user, but we still can't do anything with it. There's no interaction with it. In the next step of the workshop, we'll start adding the interaction and also start looking at how to use some of the native parts of the platform, like sharing a movie on iOS and Android. It's always nice when your IDE tries to remember how you've had it before, but you want to start fresh. So basically, the only thing I did now is the card widget we had for the list view we have here, which has no interaction at all now. I wrapped that in a gesture detector, which is another widget, which only job is to detect gestures, as the name says. And it has a lot of attributes that have already been predefined, like on long press, on double tap, on dragging, panning, and basically these you pass a function that you want to execute when this gesture is detected. And for the drag, of course, it adds some details of the position the drag is going to. Currently, we're just using the on tab for just one click. And what that tab is going to do, it's going to push a new route to the navigator, which will change the screen to another page. Also, I added a media query to the list so that we can detect what the orientation of the app is, or the phone is, so we can change the columns of the grid. So if we rerun this, still looks exactly the same, but now if we turn the app, it just changes how the grid is. So you can do a bit of responsive design on different screen sizes. There are different ways of doing this, like this one is just checking for the orientation, but you can also check for the size of the screen, the width or the height, and do things accordingly how you want to. And also, now that I've added the on tap, we should load a new page which has the movie information. Movie page. Basically, this page is also just a stateless widget because we already passed it the movie information we got in the search results and it can already start showing some additional data. So what I did is I created a scroll view, because we're going to add the description, the title, we're going to add a header at the top, and we need enough space on the screen to have that. This is quite a large phone, of course, but if you have a different phone, the screen size can be smaller or bigger, so it's a good idea to wrap that in a scroll view. So if we click on this one, it will load a new screen. And as you see, it doesn't take long because you have all the data already. Also, one of the nice things is that in Android we have like the whole activity transition. If you want to do something like I have the movie poster here on the new screen, it's on a different position. I want to animate that to another position. That can be really cumbersome to do, and if you want to make that really complex, even more cumbersome. For Flutter, that's really easy to do. In the list item, I just wrap the image we have in a hero widget, give it a tag, which is going to be the image URL, and then in the movies page, I'm also going to wrap the image in a hero. Where is it? In a hero. No, this is the header. Where is it? It's also going to be wrapped in a hero, hero widget with the same tag, so they can be linked to each other, and then that automatically gives you that it nicely animates to this position and also back again. And that's only like 2 seconds of work adding it. And another thing is, now that we start having an information page, maybe you want to share this movie with other people. On Android you have like an share intent, where you can pass additional data and share that to other applications. On iOS you also have something similar like that. But you would have to write native code and interface with that. Luckily for us, there are already a lot of packages that have functionality that are in the native side of the platform you are working with, and exposes that to Flutter. So this neatly shows us the bottom sheet dialog with where do we want to share it with. And if you're on iOS, it also does the same thing. I can show you how this works. Basically, it's a simple Flutter plugin that we specify in the dependencies part. And then here in the external libraries, you can see it. It's a Flutter plugin, which basically contains the Android code, which is a plugin to the native side of Android. And it basically only does the share intent, and the same goes for the iOS part. And you don't have to write any native code for that. It's provided in the repository already. And there are a lot of packages that you can find online. Let's see, I can show you the package manager. It's called Dart packages because of Dart being the main language. And you have different packages which can be specified for web, for Flutter, for all Dart frameworks. For instance, share preferences. If you want to store data on your device, on Android you usually use the share preferences. On iOS you use core data or something native to iOS. This is a package that wraps that API for you and provides it in a Flutter way. But you can also look for web packages which also work on web. This is, for instance, Eric's Dart. It works for both Flutter and for web and for other, which means that it can also be used on the back end. So it's a multi-platform widget if you look at it like that. And the nice thing about this repository is it's also looking at the actual repository where the code is shared. So this is in GitHub. It looks at, are there a lot of issues? How active is it? Does it get updated a lot? So it gives you a rating on how the health of the library is. Is it using the latest version? This should help with people publishing a library or a plugin and then never caring about it or not maintaining it and having bugs in it and nobody fixes it. Then you see, hey, it's got a really low score. I probably shouldn't use it. So basically we got the movie page with limited data. Now we want to have additional data like the movie reviews, maybe the genres, what this movie is part of. So we have to implement a new API call which will retrieve the additional movie data. And then we want to progressively load that in this screen. So if we go to the next step, basically we are using the same structure as we were in the main page. We have the async method call, and we use a future builder to await for the result of that. So while it's loading, we can show the minimal movie information, and after the data is loaded, check if there's an error. If there's no error, we just show the full movie information. So if I reload this application, it's loading new additional info, and now we have more to show on the screen. And you can share this with other people. And now you're wondering like, hey, this should be a cross-platform framework, right? And I'm only showing this on the Android emulator. How does it look on iOS? So if I start an iOS simulator, should have started this earlier. Now it's building an iOS IPA, and then it's going to install that on the simulator. The first time compiling of the application always takes pretty long, as you would normally expect from creating an application on iOS or on Android, but additional changes are a lot faster. So here's the app on iOS. It has the infinite scrolling list, and as you see, this has like a native feel on how a list on iOS works. You have the bounds. I hate the new gestures on iOS. If I click it, you have a different back button at the top, and you can do the swipe back gesture. Also, the title of the movie is in the middle, and this is already part of all the widgets that Google provide as part of the material design or the Cupertino widgets. They've already started with checking what platform they're running on and if they need to do anything different for that framework. So if you would create your own UI widgets, you do have to check that if you want to do something different, but if you want to create a field that is part of your brand or application, you can also skip that and do something native to what works for you. So that's basically all the steps you have to create a simple application. So I think now it's a bit time for the questions. The question is it possible to use Flutter and Kotlin multi-platform in one project? I mean, Flutter is for UI layer, Android plus iOS, and Kotlin multi-platform is for common logic layer. The short answer is probably yes, you can, because Flutter has the ability to also bind to native code, because the application that gets created is a native binary, so it can link to other native binaries. But that would mean your logic layer would also be Kotlin native. You could also do it with the normal Kotlin way, but then you would have to create a plugin that maps to an API and sends data back and forth. So it is possible, but it can be quite cumbersome. The advantage of Flutter is that something like that would not necessarily be necessary, because you can also do API requests in Dart. If you want to get files, there are plugins already for that, so you can get files in the system on iOS and Android. You can do database operations. So the question is if you would want to do it. It would add a lot of extra complexity to it. It might be wise, if you want to go the Kotlin multi-platform route, is wait until there is a Kotlin multi-platform UI framework that's probably going to pop up when Kotlin multi-platform is going to be stable. Is it possible to make layout using XML and not from code? No. Flutter has a strict policy of that everything is in code. So you don't also have to read XML and then step back to your code and context switch every time. Basically, it works the same way as React Native, where you have all the code and your UI in one language. You can compare it also with Anko for Kotlin, which also uses code to create layouts. So it is something you would have to get used to, but you can't use XML for it. Also because the discrepancies between the iOS and the Android XML would be really difficult. Are there any automated UI tests frameworks? Yeah, I didn't mention this really deeply because I hope to do another talk or workshop on that. But Flutter comes with really good test coverage, both on the unit test level and on the UI widget testing. Basically, because all the widgets are written in Dart code, you can unit test your widgets. There are already also libraries that can create screenshots of a widget in a current state, and then in the next test run, it will create a new screenshot and compare them to see if things changed, if the code has changed. This is a really underlighted subject, but it does already work fully out of the box, which is really nice if you compare this for Android, for instance, where only until the last few years testing has become a great part of developing Android apps. Are there any visual UI builder available for Flutter? Is the first question. There are some tools on the web already where you can click, drag and drop widgets in a screen which will generate the UI code for you. They're all third-party maintained, so how good they are is not really, I don't know. I've seen them really in the beginning and haven't looked at them so far. But the advantage that you have with Flutter is that if you start working with the UI, it's really fast on reloading the UI. So you just make the changes, save it, and within 1 second, it's going to be on your device or on your emulator, instead of having to have a separate window in your IDE which has to re-render. I think it isn't really necessary if you get used to it. The second question is, doing all these from code looks a bit weird for an iOS developer. Yeah, I can imagine. It's a different way of doing it. Not necessarily saying it's a bad way, but it's different and you have to get used to it. Here is, can I add cocoapods framework in the Flutter project? Basically, Underwater Flutter already uses cocoapods. I can show that in the project. If you go to the iOS project, it already uses a pod file which manages dependencies for iOS if you add any plugins that require any native iOS libraries. So you can use it. If you need to do something on the iOS side or on the Android side, you can just add any iOS or Android library to it and write the code in Kotlin or in Swift or Objective-C. Can I use standard JS or TypeScript for it? Basically, Dart was invented to be a better language than JavaScript. It's been around for 7 years now. They first tried to add it to Chrome to be a native supported language, but that didn't succeed because not a lot of people know Dart yet. But you can't use JavaScript or TypeScript for it. They do look a lot similar because Dart was started by the Chrome team to make a better JavaScript, but you can't use it. Is Flutter production ready? Would you use it for big projects? That totally depends on the use case. I know there are currently some issues with, for instance, Google Maps. It's not yet fully supported. I know they're working on it to adding it. And in the beta or the preview versions, there were also some issues with video playback. The video playback has since been resolved. I've met with the developer who was making a streaming video application with channels and switching and keeping that in sync with the other networks, which looked like it really worked good. So you would have to look at your use case. What do you need to support? Which features are you going to develop? Do you need something like AR core or something like that? Then it might not be the best solution, but you might also can get to work around it if you write a bit of native code and then make a plugin for that to go to the Flutter side. Or look in the repository if there are already plugins that have the functionality that you need to use. So it depends. Why did you start to use Flutter? The community has other cross-platform solutions. I know there are other cross-platform solutions. I've tried a lot of them, including React Native, Xamarin, PhoneGap, and I didn't really like most of them. I did a project in Xamarin, and then the project was finished. Half a year later, we had to fix some bug, so we restarted the project. Everything was broken. So it was really hard that if you use something like that, you would either have to keep up to date with everything and what's happening, and know the language you're using. And I know, for instance, React Native had some issues with performance a year ago, that it was hard to do long list views. that if you didn't know that, how to fix that, it could be annoying. And also the discrepancies between iOS and Android. If you make something for iOS, looks perfectly fine, and then you say, oh, well, it should also run on Android, right? And you run it on Android, and it doesn't look the same. I'll try to explain that to your designer. And what Flutter tries to do is it offers an actual runtime which gets installed with your application. So you don't have any native UI components. So for instance, if Samsung decides, hey, let's use Comic Sans in all our tablets and iOS phones, your app still will look great because it's not in Comic Sans. That also means that if you want to change something in the code, you can do that. The project is fully open source. So if I need to change a bug or fix something, I can actually do that in the framework. I can look how they did stuff. If you, for instance, want to know how iOS did some code or want to fix something in iOS framework, that's not really possible. Same goes for Android. Maybe on Android you can see the code, but you still can't change it. You have to file a bug, then you have to wait for the next version of Android to come out and hope they fixed it. And with Flutter, they're trying to put everything in the app. So that's why I like it. It gives you a lot of control. What is the difference between Flutter and React Native? What is the benefit to use Flutter? The difference between Flutter and React Native is that React Native still relies largely on the native platform. So instead of having components or elements that are purely in React Native, they bind to actual native parts, like a text component binds to UI label on iOS side and text view on Android side. So that makes you dependent on the platform. And also you have the JavaScript bridge that you cross a lot of times to just draw something on the screen. And Flutter basically stays in the Flutter and the Dart side, where it renders the UI totally. If it needs data from the native platform, you still cross that bridge, but only when you ask for the data, and then asynchronously you get that back. So they're not tied together, which makes it also a really fast and fluent framework. They try to target, I think, 120 frames per second, and that's like the baseline. And you don't have to do anything crazy for that to get that running, which is what I think is a great advantage for Flutter.